Hello, boys, and girls. Welcome to the stream. I'm just waiting for the shift. There you go. We've got three things here. Hello, are we live now? Can I hear myself on YouTube? There you go. We've got three things here. Okay, yeah. So it seems like I can hear myself on YouTube. You guys can see the chat, hopefully. Yeah, it is being displayed on OBS. And I guess we can get into it straight away, right? So in this stream, hello Anton, how's it going? I'm going to be continuing to work with ImGui and on the 6502 emulator. So I'll give you guys a little rundown of where we are now. I have done some development on the side. So last stream, I think all we managed to do was to add a little table for the memory offset view. And on top of that now, I've actually managed to add a little text box, another table, which shows the entirety of the content on the 0 page, right? So let's see what that actually means. So for those who don't know, the 6502 has, well, 64 point something K of memory available to it, which means you have, 64,000 bytes or something available to you in your own in your running program, essentially as RAM. Think of it as RAM. And the first FF bytes, whatever that is, what is it? Yeah, the first FF bytes is called the 0 page, right? And that is what I basically added here as a view. So we still have the demo here. So at the moment, it's still running the entire program and then showing the GUI. I know, kind of boring, but we're going to add in this video or in this stream, we're going to add like single stepping, like running the program and whatnot into here. But now you can see that we can see the offset from 00 to FF, which is F0 plus 16 of them, right? So this is the 0 page. And as you can probably tell, it's all zeros because my program that I'm running right now doesn't actually modify the 0 page in any way. But if it did, hopefully it would show up here, right? This is what we expect. So getting this done was kind of difficult, right? Because the issue I had here was it's very easy on ImGui to actually add a table. We've learned that in like several streams ago when we were doing this stuff here at the top. But adding two different scrollers where you synchronize them turned out to be very difficult, because figuring out whether or not like your mouse is hovering over a particular like child or a window. This is a window here, like this is the offset window, for example. The default flags make it so you only hover over it if you're inside the element, not on the scroll bar. So I had to like try all of the different flags and stuff. So when you actually like click on this, you can figure out, all right, we're clicking on the left pane or we're clicking on the right pane, and therefore override the scrolling like percentage on the other pane, right? So the left one controls the right one if we're selecting the left one, and the right one controls the left one if we're selecting the left one. That for some reason took to like, it was very difficult. I literally spent like 3 hours on Sunday trying to figure it out. And this is with the help of ChatGPT. This is with ImGui documentation. Like nothing was working except one particular like set of flags, which are here for those who are interested. Oh, let me just so if you are interested in doing something like that and figuring out whether your scroll bar is hoverable, you probably want to use these flags here. So hovered flags, child windows, and also no pop-up hierarchy. This is the set of things that actually worked for me. I don't know why, to be honest, but it is what it is. Now, where are we now? So I've pushed this whole thing to a PR, and I realized that my CI/CD is broken, right? So we've got a CI/CD on this project. For those who don't know, CI/CD continuous development pipeline, where we automatically build the code somewhere on a random GitHub machine, right? So that was the wrong project. And we're having an issue in the sense that it's not building. So it's the CMake stuff is just not running at all. And if we look into it, we'll figure out that it's probably because, oh, this has changed. Hello GitHub. They've changed this layout. I like it. Yeah, I'm not sure if it's weird. It's a bit weird. But yeah, I mean, CMake is not running because I've added Clang 19 support for it. For those who don't know, we are using C++ modules and with CMake as well, supporting modules. And it turns out that Clang 19 is the one that is the compiler that builds the project without errors for me, right? Because otherwise we have some like false positives of like standard header definitions being included twice or something like that, which is something we got stuck on in a few streams ago. I think it was in the last stream actually. But I've done some research and it turns out that that particular error where, you know, it complains about your standard header definitions or functions defined in those headers being defined twice is just compiler errors, really. So they are like compiler bugs, essentially. And Clang 19 fixes it. So in essence, we need to build a Docker image for this, right? I don't know how we're currently building this. I guess I can kind of figure out. So we have workflows, CMake single platform. Okay. So it's just very easy. It's just as easy as, okay, we are linting the project, apparently, with Clang format here. And we're simply just building it, right? And the change came in the preset. I think in the CMake presets, we've actually got Clang 19 mentioned in here somewhere. There you go. So this is the default compiler we're using. So there's no other way of doing this apart from just finding the Docker file and basically changing 17 to 19 here. That's all we want to do. So, and hope that it works, right? And then we can rebuild the image and yeah, whatnot. So let's install LLVM 19, Clang format 19, Clang tidy 19, Clang tools 19, 19 there. And instead of doing all of this, I'm just gonna replace all of this shit from 17 and we're gonna go to 19G. All right, so let's just make sure that nothing that wasn't supposed to get updated got updated. And we're good to go, right? So this is essentially the change in our Docker image. We're gonna rebuild that. So where are we now? Okay, I think it's in Docker. Docker build, is that correct? Urchin Golang, right, yeah. So I don't know what particular command I've used to build a Docker image, but we can figure out. So this is, if we just do history, and then grep for Docker build, this is the one. I think this is the one. Wait, which one am I actually using? Yeah, sorry, I'm not chatting too much today, but we can chat now. If you guys are watching me and you want to ask any questions, or you want to talk about anything in particular, let me know. In fact, you know, it would be good to chat to some of you because I need to release some shorts. I've not done any shorts in a while, and I need to grow the channel. So shorts are the way to grow the channel. So Matt Gomez, Jammy CPP is the one. Yeah, so this is what I've used to do. This is the one. We can just do that and change it to 001, I guess. Let's just build it, right? In the meantime, I'm pretty sure nothing will fail. Hopefully nothing will fail. But what can we do here? So we can start kind of trying to work on the next thing, which is, you know, making sure, like, I want to add some buttons to it. So this is actually going to be quite easy, I guess. But if we open up Excalibur, I want to add a centralized few buttons in there. So something like that. And this will be something like, oh, can I not? Oh yeah, single step. So we have like a few buttons. I guess we'll pause the emulation there. We have continue and single step, right? These are the things that we want. So I guess pause will be first, and then we have step through and then continue. That's what I'm going to try and add on the GUI. Would you recommend to learn Rust for the next job? I feel like I've already got some a shot that talks exactly like this, Anton. And the truth is, man, like what you do is you go on LinkedIn, and then you look for Rust jobs and see if there is a lot of them, right? So if you do Rust here, If you go on LinkedIn jobs, type in Rust. And then if you, for my case, I would like type in United Kingdom. And I would also type a Rust, well, in a search, just to make sure that we include Rust in it. And it will show you like how many job adverts there are out there for Rust. In the whole of the United Kingdom, apparently there's only 766 job openings. And this is not really a lot, to be honest with you, man. And most of them don't even mention Rust at all. So like I can tell that some of these are like just C++, C++ jobs or C jobs that I guess are somehow related to Rust because it's systems embedded, so systems development. But if you search for anything else like JavaScript, you can kind of compare. Like there's 36,000 jobs. If you search for C++, there is 23,000 job openings that mention or are related to C++. So what do we take out of this is if you really want a job, man, don't learn Rust, because there are no jobs in Rust. They're like the proportion of open jobs in Rust compared to C++, JavaScript, or anything else is just very low. So yeah, no, don't learn Rust because you want to get a job. Learn it because you want to, I guess, learn something new, right? And understand how the language works. That's a better reason for me. But yeah, it's ridiculous. By the way, the shot that we have in the channel where I basically did this and then condensed down the video in 30 seconds, it was even like worse back in the day. I think when I did the search, there was like 76 jobs available in Rust in the UK. So it's getting better, I guess. There's been a growth of 10x, I guess, but I wouldn't take that as a positive, to be honest, because there's still very, very few jobs in Rust. So that's what we're going to add here, right? So what do we need to do? We need to add a few things. Okay, so we have, okay, so if we docker push, and if I just push that tag, what did I call it? Jammy CPP, right? So Jammy CPP 00.1. Yeah, I'm pushing that to my account, which means that I now should be able to just do this here, like change the image once this gets pushed. And once we change the image, the CI is actually going to pick up the new image with Clang 19, and hopefully things should just build. So yeah. And I've not made any mistakes in the Docker file, right? Hopefully. There is no Clang 17s left in here, which is nice. Yeah. No mentions to Clang or LLVM 17 at all. Right, we pushed. Now, yeah, let's do the same thing. So if you go into development, 65K, 65K. Let's just push that in GitHub file, or so we're going to update it so we have Clang 19. We push that. And if we just watch the pipeline now, hopefully things should work. Hopefully, right? Yeah, I really like. I still don't know what to think about this new style. So this is not just new to me, right? I guess GitHub has changed for everyone. So this is different. It was like more of a list view before, and there was no styling on this. Will this pipeline work with smaller distros like Alpine? Yeah, it should do. It should do. I mean, any pipeline, like a pipeline on GitHub, works on whatever distro you have, right? So everything, like the only thing that matters here is what image you're running it on, man. So this one, for example, is a Ubuntu based one. So you can see here that I actually started from the Ubuntu Jammy distribution. And then every layer kind of adds tools that I need on top of it. So like I need all of these things to build my project currently. What else do I need? Yeah, so I also need Clang 19 tools and LLVM 19 and a bunch of other stuff, right? So that's, as long as you have all the tools that you require to build your project, it will work, right? Run Clang format didn't work, right? So why did it not work? We will figure out. So I guess it's because I've now changed from Clang 17 or Clang format 17 to Clang format 18. And that has a few different default rules that probably changed. And yeah, we just got to run the format thing, I guess. So I do have a script to format files. I'm not really sure what this is doing currently. Oh, sorry. So cpp lint is one of them. So clang format. If I do clang format 19 now instead, clang format 19, yeah. Or in fact, yeah. In fact, let me just check out that. I do want to make that change. What I do want to do is update the alternatives here. So we have clang format there. And then it's actually going to be clang format 19 there. Clang format 19 doesn't exist. What? Okay, yeah. We didn't have it installed. But now, if we do that, it should work. Forcing reinstallation of alternative clang because linking group is broken. What is my default clang format? Okay. Okay, yeah, so we've got that, which means that if we do cpp lint, we should be able to like just automatically apply the formatting to everything in Clang 19 now, which should match the data of the CI/CD now. Jesus, again, like every single stream, Bitdefender, just like it just detects that I'm streaming and then tries to like plug itself in my stream. I hate that. I absolutely hate that. If we look at Git status now, there's a bunch of shit. We can just add all of them. Fixing the formatting with Clang 19, I guess. I can't spell push. Can't spell push today. Right. Anyway, so we have 5 people watching. Welcome everyone to the stream. If you could do it, please like the video. It does help me out quite a lot, and I appreciate it. Aside from that, if you guys have any questions, if you guys want to chat about anything, just put it in the chat. I'm here for that, as well as doing coding. Yeah, so going back to the ImGui, that's kind of what we want to do. I just want to make sure that the pipeline is passing now. I want to make sure that we are Gucci. So I'm not entirely sure now. I'm so full, guys. I've literally just eaten. I've basically eaten like a kilogram of pasta. Not quite a kilogram, but literally like maybe a quarter of that in pasta. And you know when you eat too much and you sit down straight away and you just feel like you want to blow up? That's me. That's me right now. That is me right now. Right, so yeah, Clang formatting did work now, so that passed. And we want to know if this is going to install. So CPM is finally adding ImGui here. Something didn't work. Right, something didn't work, but what? So CMake lists, expected hash, actual hash. For adding raylib. So dependencies line 2. We can possibly change that, hopefully, right? So line 2. This download expected hash for CPM is different. Why did they change the hash? Why did they change the SHA-256 sum for this? What is it? What's going on? Have they been? Oh shit! Have they been hacked or something? So if I download this on my terminal, somewhere, do I have temp? Yeah. If I do a wget on that, let me just remove the previous ones actually. And wget it, and then I'll do a SHA-256 sum of CPM. We have C4 there. So the shot is actually starts with C45. C46. Yeah, C46. Okay. I guess maybe we just change that then. That's fine. That is fine. They must have changed some content in the file download. They must have changed something. Yeah, for those who are wondering, like, we have CPM here. CPM is basically a package manager written entirely in CMake. And we pull a bunch of packages with that, such as Raylib. We pull ImGui at the moment. We pull, I think, the testing, Google test for sure, and FMT, all with CPM. And there is a nice way to include it here. If you've not watched my video yet, because I do have a video on this, you can download directly with CMake. So you can just do a file download on CMake. And when you do a file download on CMake, I always recommend using the expected shot. Just because, you might be downloading something automatically every time. But if, for example, a project gets hacked or something like that, at least you kind of know that the content of the file download or something, someone has altered the download link, right? So you're not downloading a different thing every time or a different thing if something gets hacked. And this is kind of what happened here. I guess that they've changed, or I've changed the version here and forgot to update the SHA. That's probably what actually happened. Or CPM has changed the file download, or they've been hacked. So let's figure out, right? Before we actually do this, let's take a look at the CPM CMake. I guess it's not possible to change a files after the release on GitHub. No, it is possible. Yeah, you can do that, and it's probably what they've done here. So, but I just want to make sure. Just want to go into their issues and see if I'm not the if no one's complaining about it. Okay, yeah. I mean, if it was hacked, there will be like a plenty of, hopefully, plenty of people complaining about it, right? So CPM, CMake, hash. Just want to double check. Yeah. Okay. So what? Yeah. Again, Bitdefender here just being like really ballsy. This is the second time on the stream it's plugged itself. Yeah. So I think it's safe to do that. So as I said, it's very likely that I've changed the version here and forgot to update the hash, or they've changed like a file in the release, which is also fine as long as there's no one complaining. But anyway, that means we can do changing expected file hash for CPM. Let's push that. Right. Is that pipeline fixed? Because I just want to get into the coding. Oh my god, I hate this. Does anyone actually use this on Windows? The window tiled view or something. It's fucking terrible, man. Right. Pull requests again. We running, boys. So yeah, formatted very quickly. That was very quick. So we have no errors now, which is good. At least not straight away. Not straight away. Okay, it's going further than last time, for sure. But the build failed. CMake configure went through. The build failed, though. Why is that? So if we take a look at the first error, scan dependencies or whatever, scan dependency 17 not found. What the fuck? Yeah, so there is this clang scan dep 17. This is... Use a bit. Oh yeah, this is something I set in the presets for sure. Oh gosh, yeah, and that is something we've also updated or upgraded in the build pipeline. This clang scan depth 17 here is an application that scans your C++ files for modules, or module dependencies or whatever it is. I don't really know what it does in particular. I know that it does something with modules, but we forgot to update this to Clang scandeps 19, right? So this is, as I said, it's probably in the presets. So CMake presets. If I search for 17, there you go. So that was the only thing that, if I do a git log name only, I will figure out when I've changed that file last, which was probably in here, right? So this is the one, add UI modules. Okay, yeah. So if I do a status, if I add CMake presets, I'm just gonna add it as a fix up and like embed it to a previous commit. I guess we gotta do something like, wait, what? Name only, so that's 1, 2, 3, 4, 5, and 6, right? 6, yeah. Which means we can do git rebase-i head 6. And then we're going to put that in there. Yeah, now it ended up in the commit where it should have ended up, which is the commit where I've changed the CMake presets. And you know, I've been saying that the pipeline is going to pass every time I push. Luckily, it will do now though, because that was, I guess, the last missing piece. But we'll see. Yeah, we can start doing some work here, right? So let's close the split view tab. Let's actually open the UI code, which is in main.cpp. I'm going to start adding the buttons, right? So I'm going to add a function here to draw, I guess, a void, and we're going to call draw control buttons or something, right? And we are going to take the emulator CPU here, just so we can see the state of it. And we're going to do a bunch of like ImGui button draw calls, right? So first of all, let's do a ImGui begin child, call in here, followed by an end child. Now, do I want some flags in there? Probably not, I guess. Or probably, I don't know. Offset view. So this is the width and height. Yeah. So what are the flags that I want here? So scrolling region. So first of all, the name and then the size, which is imvector2. We do have a bunch of flags. I kind of want no border though. No border. Is there an option for it? No decorations, no title bar, no flags, resize, no scroll bar, no collapse. Okay, no background, menu bar. I guess no decoration would be nice, right? So that's kind of what we want now. Either way, let's copy that. Paste it here instead of this one. This is going to be the control button view. I'm just going to get the region available size, avail. Or is it? What is it? Get region. Get avail. Get content. Yeah. Get content region available. And this function, what it does is like you can kind of query the available size of it. So like before you begin creating the child, the get content region available is going to kind of show you or get you the remaining size in that window that you're creating it in, right? So you can kind of like manually do things like centering objects or making sure that your window is only ever like 30% of the available size and so on and so forth. Because very annoyingly, ImGui doesn't actually let you set like, you know, I want this item to be centered kind of thing. There's no, what's the word? There's no like flex box as you do in CSS here. right? There's nothing like that. So it's not very nice to kind of do centered elements, but we do need available size for sure though. Now, what does that want to be here? So imVect2. It's an integer, so auto int or int const. So button control button height or button box. Let's call it that. I need to move my mic because like it keeps getting on the way of me typing. It's annoying as fuck. In the meantime, the build still failed. Failed big time actually. But he got a lot further now though. So headers, const per variable, cannot have non-literal type. What? Okay, I see. So string, std string is not a literal type apparently, even though it should be because we are in C++ 20, right? Or 23. We can fix that though. We can definitely fix that. We can fix that for sure. Anyway, so going back here. So int const button box height. Let's do 100 pixels, just for the sake of it. imVect2, does it take an integer? That's what I wanted to see. Float, it takes a float. Okay. So ImGui window flags, ImGui window flags. The one we actually wanted was this one, right? What am I doing here? Let's go down. Let's go down to where we were. Where the hell is it? Here. That's the one. Hello, GTX. How's it going, man? Good to see you here. I thought you're not going to join today. For some reason, I thought you're busy with your university work, as you should be doing now, right? It's nearly the end, man, I guess, right? Finally got a job. Yes, I saw, man. Can we all get a... Oh, I'm going to put it here. A little party thing. For the 4 people watching, can we get can we get a little party thing? So GTX has done what many of you, or many of you are trying to do, I guess. He's got a job this year, and dude, that is an amazing achievement. So you should be proud of yourself, especially when you got a HP job, man. That's a very good first company to start. So well done, man. Well deserved as well. This guy just, he works very hard. For those who, join the stream, we have 5 people now. For those 5 people who are here on the stream all the time, and you see GTX here on the stream all the time, actually working his ass off, doing his university work on the side, you know that he deserves it, right? So, very well done, man. And I wanted to ask, is a university course also finishing, man? Because like universities usually, at least here in the UK, they finish in like end of April, May, if it's your last year. Maybe June if you have a really late exam. But either way, we're very close to finishing, right? So it's an internship. It's more finance and admin than development. It's still interesting, yeah, for sure. I mean, it's still experience, right? It doesn't matter what you're doing. You got some experience now. So let's look at how we can style a button in Excalibur. ImGui button examples. I guess it's just ImGui button, right? That's what we have here. So if the button is clicked, then there's a... Yeah, I had seen this before. So we're going to add 3 of these. So format that. Which of the buttons we had? We have continue, we have pause for sure. And pause the running emulation, right? Pause running emulation. Why did I just... Okay. We had pause. Do we want to... Yeah, we want to do that, or we want to step through the code, and we want to continue, right? So we're basically doing a debugger kind of thing. Right, let's get the chat here. So it's an internship, small finance. Some unis do that here, but normally they finish in the summer. So I still have a bunch of time till 31st of May to hand it in. I'm going to hand in the documentation so I can write it in English. So you can all read and docs myself. I'll be interested to read your dissertation. What do you call it? Yeah, your dissertation writing, right? It's what it is. We don't call it quite documentation here. It was like a full... I'm not sure if it's the same for you, man, but when I was at uni, I had to do a full, something like 40-page document explaining like everything that I implemented and all of the methods and, you know, all the sources and so on. It's kind of cumbersome, to be honest. It's like, of course, it's not as hard as doing the actual coding, but, you know, you can't just bang out 50 pages in a week, right? So it's something you have to do from the start, which is something I definitely struggled in at uni. So I was amazing at the coding side of it, but when it came to the writing, man, I really struggled to just sit down and just write shit. That was not my thing at all. It's mostly physics right now. It's already 30 pages for the theory. Yeah, that's good. That means you've got a lot of like jargon to bulk out the pages, right? Okay, so this is step through an instruction. And then pause or continue running the program, right? Something like that, I guess. Yeah, let's do that. So if we build this, I just want to see what it looks like. We don't actually have anything though. So if I call draw memory view, so if I call draw, what is it called? IntelliSense, why is it still not working with Clang 17 in 2025? C++ modules, sort your shit out. Draw control buttons. I'm going to copy some of these here because it kind of looks neat to have that. Drawing the control buttons at the bottom. Okay, that means we can build this again. I have to fit it into 40 pages, but I don't know what I will put into the implementation part. I have to fit into 40 pages, so that leaves me with only 10 or 15 pages. Pro tip, don't use modules. Yeah, pro tip, don't use modules. That's good. The pro tip I'll give you though is that if you have all of that, if you have 30 pages of just pure math, then maybe get rid of some of it, man, because your whatever he is, the supervisor, I guess that's what we call him. He's not going to be reading all of the maths and understanding it though, so you might as well just get rid of some of it and use like some of that space for actual documentation if you need it. If you don't need it, then leave it on just so you can say you've got 40 pages. But yeah, that's kind of what I had as well. Like I had a bunch of like just shit that people weren't going to read or understand, especially my supervisor. Like if you derive formulas and stuff in your dissertation, formulas that you can just kind of Google where they come from, then yeah, you can probably save some of that. My supervisor is the physicist. He needs me to understand it. Yeah. I mean, I'm sure he knows that you understand it. The point is, I don't think he will care if you don't have, oh, what's going on here? Okay, so we have pause, step, continue. I want to do it on the same line. That's what I forgot to do. So I'm sure he doesn't expect you to write like the derivations of every single formula and proof of every theory that you're mentioning though. If I need to cut it, I will cut it. Yeah, that's what I mean, yeah. If you need to cut it, cut it. All right, so we want to do the same line here and here as well. Ooh. We can do a build. Now we should at least be all on the same line, hopefully. Hopefully. Right? And then we can think about centering it. Now, that is good. So we've got pause, step, and continue, right? Now, how do I make the buttons all have the same size in the first place? So those are two things I want to do. Make sure that the buttons have the same size and also center them. So set. Yeah, so I want to center them. How do we do that? I still need to write some par. I found a very interesting paper about calculating the moment, mass, center of mass, inertia of a closed mesh in ON time. That's good, yeah. I mean, these are things you should be talking about for sure, though. Like, here's a paper, here's how they've done it, and this is how I've implemented it. So, yeah, in ImGui, you can set the cursor to somewhere other than the left, right? So you can kind of add some padding on it. My original solution was ON quadratic. Quadratic. Wow, dude. Quadratic, no. N to the 4, yeah. That's a different name, right? Dude, yeah. Okay. Yeah, so let's figure that out. So first of all, I'm pretty sure that we need to... Well, let's try and get the buttons all the same size, first of all. So ImGui, button, quadratic n squared, yeah, it is. ImGui button styling. So I want to set the size of it. Button. Oh no, it does take a few things, right? So if I do ImGui, if I just search for button. Ah, yeah, so it has a bunch of shit. It has the size on it already. Sweet, I guess. This will allow you to step through the instructions. Yeah, so that is the plan. So we want to step through the assembly. Basically, you're making a debug. Not quite. It's an assembler, really. I mean, it's yeah. I mean, it only runs code for 6502, right? That's the thing here. So we can pass an IM to ImVec2 here. So I guess what we can do is auto const button size, right? Which is ImVec2. And then we have the width and height. So width, let's say it's something like 50. And height, 20. Is that going to work fine? And then we can pass in this button size to every single one of these. And apparently things should work. Button size. Button size. Let's build it. Let's finish whatever's going on now. If there is no feature for layouts, then the simplest way to divide the container width, yeah, minus the gap. Yeah, that's what we want to do. So to center it, you have to kind of divide, you have to get the available space, first of all, without the buttons. Then you want to subtract the whole width of the buttons, I guess, which we know is going to be 50, right? Minus the gaps as well, and then divide it by 2, and set that to our cursor. So there is a function called... Let's see if I can find set cursor or something. Set current, no, set cursor. There is a function to like tell ImGui where to start drawing from. And that's what we're going to do. There you go, cursor position. So cursor position in window local coordinates. This is not your best friend. Apparently, that is not our best friend, so we shouldn't use it. But we can try it out anyway and see what happens, right? I just want to see what they look like now to see if the buttons are kind of okay. So we did 50 by 20, I think. that right? Two gaps between buttons. Yeah, indeed. So those are the things we kind of want to... So, okay. It's not enough for the continue. So we need to kind of add some girth here, so some width on the buttons. Sorry about that. Sorry about that. This is still child friendly. There is a good library written in C++. There is also a good library written in C++. Good story, but cool story, bro. It's like 2 kilobytes of header files. Are you talking about ImGui? Yeah, ImGui is written in C entirely, and it's large, yeah. So maybe it's over 2 kilobytes for sure. But I find it's a pretty good library. I can't complain about it. It's really good. So yeah, that's more like it. You can calculate button size with formula, specifically if you have a width change handler. Okay, that sounds complicated, not gonna lie. That sounds very complicated. What I'm thinking is just, kind of getting the values, the available width here, minus the 70 times 3, and whatever this gap is, which I think is 10. Yeah, I think it's 10 by default. We've got a similar calculation for the bit at the top, though. So for the memory view, sorry, not the memory view, what is it called? Table view? The table view? Is that what it's called? I've got it here somewhere. There you go. So for the table view, we've got a similar calculation where we get the available height minus the margin times 0.5. That's the table width, right? Which is roughly about 50% of my content, and I leave some margin at the middle. Yeah, it's not quite the same calculation actually. Send link. Let's see that. It's safe for work, right, man? You're not scamming. You're not pranking me here, are you? I need to stop opening links on the stream. I know it's really bad, really bad, but Nick Breaker, dude, I'm gonna open it on a tab on the side. Okay, yeah, that sounds good. Clay is a Flexbox style UI auto layout library in C with declarative syntax and microsecond performance. That's good. High performance. Okay, so you can try changing renderer, canvas renderer. Oh, okay, so this whole thing, I guess, is written in the C library here. If you change it to canvas render, which is cool for sure, and it all just works. Yeah, but the thing is, we can't really integrate this to whatever library we're using now, which is Raylib, right? Not easily anyway, I suspect. But I would definitely take a look at it, man. This is really cool, though. Can I see what it's like? So Discord docs. So GitHub. Let's go on GitHub. Also, please ungroup this. It has Raylib renderer. Oh, mate. That is incredible. It's got 10.9 thousand stars. That's pretty good. Really good. Clay. I really like the name as well, like C layout Clay. Oh, this person has transcended right there with that naming. Microsecond layout, Flexbox like layout model for complex responsive layouts, including text wrapping, scrolling, containers. This is everything I'm struggling with at the moment with ImGui. Everything. Example of Clay compiled to WASM. Yeah, so they compile it to WASM and running in the browser. Others in the examples directory. You can also watch the introduction video for Motivate. This is really good. I didn't know about this. This is really good. How does it compare to ImGui though? ImGui. Has it actually got more likes than ImGui? Nah, not quite. ImGui is still king, but this is, if it's easy to use as well, let's look at the code here. Play implementation. Wait, is it header only as well? What the hell? Okay, seems to be header only. Syntax a bit messy though, I'm not gonna lie. Syntax it looks a little bit messy. You don't even have to leave C if you want to make a web app anymore. Yeah, you don't even have to leave C, no. You can make a game. You can make a game entirely in C now for the web, and then just compile it for WASM. How good is that? How great is that, by the way? If you think about it, like up until now, up until a few years ago, if you want a web application, you need to learn JavaScript, right? That's just what you do. JavaScript, HTML, CSS, learn how to use the canvas, learn how to efficiently draw on the canvas, and that is it. That's how you create games for the web. Now we have gone back into Monkey, and you can literally use a very low-level language like C and use a compiler for WASM, right? So, and that whole thing is basically compiled into WebAssembly, which is supported by most browsers today. And you can once again have your shitty Flappy Bird games written in C, compiled for the web, and have your source code in a state where no one really understands it on the browser. The only understandable code you have is locally, which is like, if you think about it, is a way to kind of close source the rendering code. Unless, you know, the person who's actually looking at the code itself, or the WASM code is good at assembly, right? And they can kind of just read it with their minds. So it's cool. I find that really cool. I find that really, really cool. In fact, let's try and read the assembly here, just so you can see like my point. So like, obviously, you know, you understand all of this. So a script type module. So this is all, I guess, JavaScript. But if we swap it to canvas rendering, where is the WASM? Where is the WASM? Can I open the, like, how do we actually get the WASM here? Okay, now change it to canvas renderer. Did we see network? Let's try that again. Let's see if I can get it from network. I want to see just the WASM and what it looks like. There you go, index.wasm. Can I copy this? Can I open this? Plate, I guess, index.wasm. Oh, there you go. That was easy. You can make a playable game with it if single render takes under 60 milliseconds. Yeah, I mean, you got to see if it's actually faster. Like, even though WASM is supposed, you know, in theory, supposed to be faster than JavaScript, it ends up not being that much faster anyway. There you go. So this is what I mean. Like, so your entire rendering code is just unreadable. Like, no one can read it unless you know, the person reading this is very good at decompiling it. So they have to run this WASM file through a decompilation process and then get I guess the assembly out of it. And kind of like they have to reverse engineer the code to understand how you're drawing things, which is cool. Because with JavaScript, obviously you kind of have to have some JavaScript on the front end side of things. And even if you minify it, it's still fairly easy to kind of get back the original code from it. But with, you know, C and C++ being compiled for the web, it's now harder. So you can essentially close source everything. And I like that. I very much like that. Anyway, I do like this. Let's get back to ImGui and done programming. Without Flexbox, unfortunately. Without Flexbox. Yeah, so going back to this, we have the available size here, which we're not actually using it anywhere. Can I do that? No, let's just begin a child here without the button height, right? So that's 0. And what we're going to do now is call to ImGui set cursor position. Is that right? Set cursor. Yeah, there you go. So set cursor position X. Initial cursor position and window local coordinates get cursor screen position after begin. Yeah, so we get cursor screen position. ImGui get cursor position X. Is that correct? I am not on JavaScript. Also const current position. So we've got the current position, the current X position, right? And what we want to do is we want to set the cursor position to the current position plus whatever the height is. So for example, if we're just doing it by eye here, so it's 70 pixels wide for each button. We have 210 pixels plus something like 20. So, you know, let's put 230 there, right? And that's what we kind of want to do. I just want to see if this, in theory, would make sense. So if we can set the cursor position for drawing manually, and if it looks right, just so I can center something on the screen. Just so I can center share. Okay, yeah, it kind of works, but obviously the offsets are kind of wrong. So this is what we got here, right? So the actual maps that we need here is obviously the entire available size minus this divided by 2. All right, that's what we want to do. So let's try that. So whenever I had 230, that's where we set things. So we want to set the cursor position to roughly where we would end up centering the buttons. Okay. The current position is that. Also const available size. Oh, we can't reset available size, right? So I guess button control size, auto const. I call it available size here, but I don't actually use it anywhere, do I? Yeah, there you go. If we call it out there, it will be the available size before the child has been spawned. So in other words, before the button box has been created, and that's not going to give us the right one. But if we call it here, so ImGui get content region veil. Now we can do that. So we can do the available size.x minus 230. Something like that. Divided by 2 or times 0.5. And we do the current position over all of that. Hello, Slim. How's it going, man? How's it going, my man? So what's going on here? This has high precedence than plus. Yeah, that is correct. That is correct. I mean, I wanted to do that anyway, but let's just make it clear. I had to leave, but I want to see your reaction for Clay, so I'm watching at 2x speed. Yeah, no, it's really good, man. I'll save you watching at 2k speed, 2x speed, but it was really good. I think that is a very good contender for making like easy C applications for the web, like games or whatnot. I would like to see like how fast it actually is compared to just drawing in JavaScript on the canvas, because I whenever I see like big claims like, you know, it's microsecond rendering, what does that mean? Does that mean it's actually faster than JavaScript? Because JavaScript can also be microsecond rendering if you do it right. I'm behind 7 minutes. Oh yeah, so you're not seeing this. I'm going to stop talking. I'm going to stop talking. But Clay seems good. Clay seems really good. For those who just joined, we were looking at Clay. So clay C layout. It's kind of something that is like a GUI library, I guess. I guess kind of like ImGui, but it's got Flexbox in it. So why would you not want that? So it's got Flexbox, it's got like text wrapping and everything built in for you. The only downside that I can see here, as I said, is probably just the syntax. It looks a little bit messy, to be honest, compared to ImGui. But that is just me. That is just me. Maybe we'll test it on the stream one day. No difference for Clay versus JS because WASM has no access to DOM or window object. Oh, is that true? So you can't actually get like... Wait, no. So how do you render on the canvas if you can't get access to DOM or window object? Yeah, so how... Really? I didn't know that. So obviously on JavaScript you can... Oh, there you go. So is it centered forever now? Okay, good, boys. We are good. Now, you have to have a code that communicates with WASM. Ah, right. So you need to have JavaScript that communicates with WASM. Oh yeah, I do remember that. So I did do this. I did do a bit of M scripting on stream, where we had, I think we actually compiled ImGui for WASM, and it generated like a JavaScript module that would call the WASM and then control the rendering with it. Ah, yeah, cool. I didn't know that. I thought you could access the DOM objects directly from WASM. So it's a shame. Shame. So when does it become too crowded? Like there, right? So this is where it becomes too crowded. If we allow us some leeway, what is this height here? If we take a screenshot, again, we're going to be very lazy. Open this on Paint and see what the 745. 745 is the minimum size that we want then for the window. Yeah, but it still has to be faster because the code is not being interpreted. When you have JavaScript and you can create a closure temporary, is WASM? Yeah, WASM is not interpreted, right? So that's a good question. Let's ask ChatGPT how WASM actually runs. So how does WASM run in the browser? And I mean, JavaScript, you know, I'm asking compared to interpreted JavaScript, but JavaScript isn't actually interpreted all the time. You guys know that, right? There is some just-in-time compilation, which makes things a little bit faster. So WebAssembly code is pre-compiled into binary format before being executed in the browser. It's compiled ahead of time. Yeah, in effect, low-level bytecode is cool. So it's still bytecode. It's low-level bytecode. It's not necessarily just running, you know, on your CPU, which is what I... You know, if this is right, if GPT here is right, you still have something akin to like Java, for example, where there is a JVM there in the browser running the bytecode. It's just at a much lower level, indeed, but it's not necessarily not interpreted. I wouldn't say it's not interpreted. That's my point here. Yeah, JavaScript has just-in-time compilation. Depending on what you're writing, will compile ahead of time. Performance. WASM is faster than JavaScript in most cases because it's low level, statically typed. Okay, he avoids the overhaul of dynamic type checking and garbage collection. Okay, I see those as the actual benefit of WASM, like no garbage collection and no type checking, no dynamic type checking. Yeah. Now, in theory, what is the actual speed of WASM versus JavaScript for performance, right? So what are the latest data that we can see here? So that was 2 years ago. We've made a long way now. So if I just search for, I guess, results in the past year, I guess, or even month. So this is 14th of March, 2024. Still like over nearly a year out of date. So portability, is there any graphs here? I'm looking for graphs, my man, please. This is probably just an AI written article, isn't it? I mean, let's see if Reddit will give us something nice. Because the point is, like last time I checked, WASM was only something like 6% faster than JavaScript. I remember seeing it on a benchmark somewhere. I can't remember which benchmark it was, but it wasn't that much faster. But last time I checked was also something like 2 years ago. I wonder if it has become faster now. It's faster if you delegate a map to WASM. Yeah, but you can prepare the image in WASM and just forward the data JS, then it can be faster. I'm still 3 minutes behind Google benchmarks. Okay. Yeah, no, I'm just looking for a bench, a WebAssembly JavaScript benchmark. That was easy 6 years ago. SitePoint. They tend to be good. SitePoint. So let's disagree with that. Do they have any data that I can actually use here? Okay, so Rust code. So they are compiling Rust to WebAssembly. And the JavaScript function. I mean, I can kind of guess whether or not these are equivalent. So we add two numbers, okay. Load WASM, okay, JavaScript. Where is the equivalent JavaScript? I guess it's just an addition somewhere. Oh, it still doesn't have any kind of data. Dude, I'm not seeing any like good benchmarks at the moment. You can compile C++ code using mscripting. Yeah, that's what I used before. WASM isn't necessarily faster than JS. That was 2 years ago. In fact, I might have seen something like this. Easy benchmark. Collision detection. Okay, I mean, where is the actual... Okay, we can run it. Check inequality. Wait, what is this doing? Is this running... Hello? Okay, yeah. I thought my computer just crashed. Ah, this is cool. So this is actually running this code and this code. I like this. I like this. So this is what I'm looking at for those you can't see. Can I post link in the chats? Let me know if you guys can see it. You will not get super performance because you will be limited by JS drawing on canvas. Yeah, I mean, this is not drawing at all. This is just calling some JavaScript code that does the same thing as that and compares the two. Obviously, when you look at something like this, you wonder, is the C code written in the best possible way? I don't know. I can probably guess if I look at it for a long time. Likewise, is the JavaScript code actually the same? Structurally they look the same, but would you actually write this JavaScript to do this sort of thing? That's my question. It seems like it just transpiled one to the other. But if we ignore that side of things, and if you just take this as the ground truth for like, yes, these two programs are equivalent, then we can see that WebAssembly here actually takes longer than JavaScript for collision detection code. So Fibonacci, this should be an easy one. Let's see how fast it actually looks. WebAssembly just didn't run. So for Fibonacci, it's actually a lot faster. I'm not sure if that's my browser being an idiot. Let's try and run it again and see if we can get consistent results here. But yeah, in this case, it makes sense because JavaScript, yeah. So WebAssembly, when you compile this code in C, the compiler might be doing something fancy, might be figuring out this particular bit of code can be, vastly improved if you implement some sort of memorization technique, right? So this is something that could be happening in the C code, and obviously doesn't happen in the JavaScript code. So this, yeah, I would expect this to be a lot faster just because of compiler optimizations. But I wouldn't say that this is a real world problem, would you? Like, you're not really calculating Fibonacci numbers up to like 50, like the first 50 Fibonacci numbers. This, you're never going to do that in the web page, right? You can just have a list of pre-calculated or precompiled tables. Image convolute. Again, is that something we do with JavaScript? But we can check it. It's very mathematical heavy, for sure. So not much there, to be honest. I mean, 59 milliseconds to 50 to do image convolution. So applying a filter to an image, for example, where the filter is a kernel, a smaller kernel. Image grayscale, turning an image into grayscale. Let's see. So WebAssembly actually takes a lot longer than this. Yeah. So it's a bit of a hit and miss, really, depending on the operation that you're doing, right? I don't really see any massive benefit at the moment. Now, let's try and pick something that clearly is going to do well on WebAssembly here. I guess quick sort of doubles will do well, right? The reason being is because JavaScript has numbers and it has to do like a bunch of dynamic type checking in this case for the quick sort. WebAssembly, statically typed C, compiler optimizations. This problem is actually very, very common. I'm sure the compiler writers have probably optimized every single operation that goes into this quite a lot. So we can see. I expect WebAssembly to do better than JavaScript in this case. Or maybe not. Oh yeah, it does. It does better. But not by a lot though, as you can see here. Not by a lot. So it's 300 milliseconds versus 200 milliseconds-ish. Yeah. Now let's try and pick a problem that is obviously better on JavaScript side. In other words, where it doesn't matter whether we do it on JavaScript or this. I guess I can't really tell, to be honest. Video marker detection, maybe. What is this doing? So original, let's run that. Okay, this is cool. Yeah, as I expected, JavaScript is doing better. My browser has just been a bitch here, guys. I'm sorry. Yeah, but JavaScript is a little bit better, just because it isn't mathematically heavy. I guess this is actually running some sort of model that, yeah, I don't really know, but anyway. So you get the point, right? My whole point is WASM isn't really that much faster than JavaScript at the moment. So I think we still have a long way to come. You will not get super performance. I checked that. The compilers are okay. And the optimizations that come from that are the main thing, I think. WASM is the way to run an FFmpeg in the browser, by the way. Yeah, I'm sure it is. Because, you know why? Because FFmpeg is probably entirely written in C. So it's just easy for them to compile it for the web. And it's equivalent, as we saw, like the video operations and image operations. JavaScript is equivalent to WASM. So it makes no sense for them to rewrite something like that in JavaScript, right? But FFmpeg has been in the browser for a lot longer than WebAssembly, though. It's probably just been there as a plugin. I'm not sure if it uses WebAssembly now. If you got any sources on that, I'd like to read it because I don't actually know. It's more of a mixed bag than I expected. Yeah, it's more of a mixed bag than I expected. I kind of knew that because I did some research into it a few years ago. But yeah, it's the idea of compiling things for the browser is definitely cool, right? You can close, as I said, the main benefit is probably close sourcing your stuff, like close sourcing the rendering for a particular like game or something like that. Aside from that, there isn't really any performance benefits, in my opinion. So if you're going to kind of convert your entire JavaScript code base into like C or C++, just because, or Rust for that matter, just because you want to compile it into WebAssembly, and you think that's going to be faster, you know, it might be a waste of time. That's the point here. If there could be an engine optimization for the VA, maybe. Yeah, you know, my prediction for the next few years is that WebAssembly will get better. I mean, there's a lot more people doing WebAssembly now, or WebAssembly compilation from languages like Rust, Zig, C, C++. So my guess is that these things will continuously get optimized and faster, right? But these things take time. These things take time. There is a song by the Smiths that goes like, "These things take time." It just reminded me of that for some reason. You can make it really easy to make multi-platform things. Like you can write C. Yeah, that's another benefit. So another real reason for doing it. Like I can probably compile my code. Should we try that? Should we try that in a following stream, in a future stream? Try and compile the emulator for WASM, right? And then have it running in a canvas. I think that would be a very good exercise, which kind of shows the benefit, which is, yes, you can write things for your computer, for your system, or you can write it for the web. That's an option as well. By the way, the title says CI/CD. We have done some CI/CD, man. We have done some CI/CD. You just missed it. It was at the start of the stream. We'll go back in a second because we have a pipeline that's currently broken, so we need to fix it. But we have done some of it. We fixed some of it, in fact. So, yeah, this seemed to have worked. We have begin window. What is it? Begin child. No. Bro, where is my minimum width? Begin child there. Emulator, push that bar. There you go, minimum size. I think we actually had this, right? So it can't go under 745 pixels for the window width, which is kind of what we needed, I guess. Let's see. VA has turbofan. I don't know what that is. I know what V8 engine is, but I don't know what turbofan is. Okay, so this is what we have now. This is still halved, but now we can't, we can't take it lower than this now. You see, we can't resize it lower than this, which is good. I kind of want to run a program that will change some of the zero page. Yeah. When I switched to use that ON algorithm mentioned earlier, I also parallelized the other parts of my program. Altogether went from 10 to 15 seconds to almost, that's really good. That's really good optimizations. Oh, GTX was asking for optimizations. Okay, so I guess that's some sort of optimization engine in there. Right. I say that we probably have it. Okay, so that minimum height is kind of broken. A little bit. What do you guys think? Yeah, so it should really kind of go down to here. Right? Yeah, that's kind of what we want. So let's take the measuring again. Let's probe this. So what's the height of this? Edit in Paint. Come on, Paint. Tell me. So 345-ish. Yeah, 345 is the one. So 345. And something that actually looks nice. Kind of. I still need to get rid of the borders in the child, like windows, because it makes it look odd. You can kind of see the blank spaces, but yeah, it is what it is. Okay. Now. Okay, good. So we can't take it lower than, or take it under 345 pixels height, which is good. These buttons don't kind of do anything yet. but we're going to add some functionality to it. Now, I want to see if this memory view is actually working, right? So I want to kind of load a program that will change some of the stuff. So we have the actual program that's drawing my face at the moment. This is it. This is the program that's loading all of the data. So what we're going to do is we're going to find a compiler for 6502 assembler. That's what it's called. And we're going to add some stuff to it. So move SDA. Okay. We're going to add some SDAs in here. Load into the accumulator, store it into there. So we're going to store some values into, I guess, the 0 page, right? So if we load something like, I don't know, FF for the sake of it, and store it in 00 FF, and then do a few of these, right? Just so you can see that this thing is working. Oh no, that's FF, FD, so FE, FF, FD, FC here. Okay, yeah, let's assemble this. Change the code slightly, so we also change the 0 page. And we do need to assemble it, to be honest. Okay, so if we download the binary, generate binary, click here. Okay, so we have 06502, that's the program. That means we can kind of put it in here, I guess. So if we move it from my Windows machine, I'm going to see C downloads, users. Five. Okay, if I move into that and change the running program. In other words, what if I go into here and then change it slightly? So we have Robin's code v2. Right, that should at least show us some stuff in the memory view. I will soon enter slumber. I have to get up at 6 tomorrow. Dude, just go to bed. What are you doing here? Make sure you like the video first though, then go to bed. Robin's code. Hello, Robin. You're watching us, man. I'm still using your code, man, to do the testing of everything. The only criticism is that it doesn't change the 0 page, so I couldn't really tell if my memory view thing was working, because it doesn't seem to be working, you see. Doesn't seem to be working. Why? Hello, Jonathan. How's it going? Lurking while I work. Welcome, man. Welcome, man. Yeah, so why did it not work? Why did it not work? We do have SDA. Load that into FC and FD. And then just to make sure, mass work. Ooh. Let's look at the instruction set. So we have SDA, a bunch of them everywhere, right? So store accumulator into a bunch of places. Let's look at, okay, 0 page there. So SDA 0 page. Opcode is 85 and it takes 2 bytes. So, right, this is probably because I should be using the 0 page mode instead. Right, so basically if we do this now, okay, let's see if that's going to work. Assemble. Download binary. Generate. Okay, let's move the same thing into here. And it was 559. Okay, yeah. Robin's code v3.binary. I'm going to change it again. Oh, wait. I kind of... Oh, yeah. It's probably something with my code for sure. But if I change it now, Robin's code v3. And then I rerun it. Avengers Assemble. Yeah, we've got all the OGs now here. The pressure is on for me to get something working. Hopefully it still runs, at the very least. But then when it comes to drawing, I can kind of see... I can run this again and put a breakpoint to see what's on the... Yeah. What I think is happening is that I'm not actually putting meaningful values in here. I'm probably just hard coding zeros everywhere. Right, so if I go on draw memory view, yeah, draw memory view, this is where we're drawing everything. And then we have 16 columns. The memory, okay. 0x2 memory.column. Yeah, what do we get here? What do we actually have? In other words, like, does our CPU actually have the memory set to something? You can do it, Matt. I secretly hope you will fail so I can laugh heartedly. This is also a joke. I like it, dude. Right, so memory element. Oh yeah, this is where we have to use the freaking debug console. CPU.mem. Yeah, so there is a way to print p-array, I think it is. p-array 10, something like that. Can we do the first 100? Oh yeah, we can do the first 100. There you go. But what I really want is the first, let's get a calculator. 16 times 16, 16 times 16. Wait, what is FF? Wait, what is FF? Is it 256? Yeah. Programmer, FF. Yeah, 256. So we need to do that 256 times. And we do have them set. See, they are set. So the problem is the view, for sure. The problem is the view. So in other words, the problem is this code here, this particular bit, isn't quite working. What have I done wrong? So for every row in number of rows, a number of columns, right? So let's just do a breakpoint there. We have 16 by 16, which should be 256, right? Why am I doing 16 times 16 in a calculator or not in my head? I don't know. Yeah. I always doubt myself when it comes to simple maths, even though I have a math fucking master's degree. That's what really annoys me. I'm not sure about you guys, but I know there are some people here in the chat who have done a master's degree, or part of your degree was mathematics. You know, when you tell someone you've studied maths at university, and the first thing they ask you is like, oh, what is 276 times 1,337? And yeah, they expect you to know how to do that kind of shit in your head. And it also annoys me when I can't do simple stuff in my head, which is really annoying. But yeah, that's a conversation for another day. So 0, 0. . Oh yeah, the maths here is wrong. Can anyone tell? Can anyone tell what's wrong here? I'm trying to print this array should be printing all of the bytes from the byte 00 at column 1616, which should be 256. So in other words, this should be going to like 0, 1, 2, 3, 4, 5, CPU memory 0, 1, 2, 3, 4, 5, up to 256. So I'll give you guys like 2 seconds, and well, maybe I'll give you guys like a good 30 seconds. And if you guess it, you can probably work with me already. You can get a job in my company. Yeah, GTX got it. There you go, GTX. That's why, man, you've recently got a job, because you can solve this kind of stuff in an interview. Yeah, it should be row times the number of elements in the row, right? Which is 16 in my case, right? So in other words, yeah. Row time number of columns in this case, right? Because each row has 16 columns, so the one has 0. When you're at row column 0, you know, you should be going from 0 to whatever, 15. And then on the first column, you should be going to, well, 1 times 16, you know, time plus 0. There you go. It should have been that as well. Up to, you know, 16 plus 15. So yeah. Probably. I like the answer, man. Yeah. I times row plus col. Probably. Yeah. It is 100% right. Yeah. You didn't put it in the, you know, in the format of my current code here, but I'll let that slip, man. Well done. Well done. I'll give you a little heart emoji there, or 100. I don't know which one it is. Before I go, do you think this is a good title? Mesh generation, real-time visualization, physics simulation, collision detection for rigid bodies. It's a really fucking long title, man. Not gonna lie, it's a long title. But if that's everything you did, then yeah. Yeah. That's badass. That is badass. I like the title. It has a lot of things. Yeah, man. Jack of all trades, master of none. That's all I'm saying, right? No, it's good, man. It's, you know, it doesn't really matter what the title of your university's dissertation is, because they're all crap. They're all crap, man. I'm not even joking. Just go and look at your colleagues' titles and you'll see, like the previous years, they're all crap. Everyone is bad at writing at university. No one's good at it. It's going to be coding multiplayer web servers one day. I'm going to be coding multiplayer web servers one day. Yeah, you can do that now, man. Let's get on Minecraft. Start writing plugins for Minecraft. Right. Now, with a bit of luck, you know, that's what we're going to get. But only in C++, yeah. It sounds more fun than it actually is, I'll tell you that. I do that for a job, and it sounds more fun than it is. Ah, food acquired. Yeah. Is it noodles by any chance? I swear, Robin, whenever you show up on the stream, you're always eating noodles, man. Like any good programmer, I guess. Right, so there you go. So now the display is probably working, right? It's probably working. We can see the stuff that we set in the end, which is good, right? Really, really good. Now, yeah, let's get back to CI a little bit, because we do have a pipeline broken. I'm going to push this whole thing so we can merge it in. Obviously, in this PR, we don't yet have like the pause functionality. We don't have the step through. That's something we're going to be adding next time. So you're going to be able to kind of step through like each instruction. Maybe there'll be like another window showing the actual decompilation here, I guess. Yeah. Yeah, so we can do that. We can take in a binary and show what the assembly would be, and like a line on where you are. That would be cool, wouldn't it? Yeah, why not? We can do that. But for now, let's push this. Let's fix the CI, and yeah, try and do that before the end of the stream. So you add, not today, it's minced meat sauce with pasta and some pesto. Dude, minced meat sauce. There's a name for that, you know, Robin? You know the name for that, right? It's called bolognese. Bolognese. The Italians would kill you right now, man. Unless you haven't actually made a bolognese sauce, you just half-assed some tomato sauce and minced meat. Right. Is Italian food popular in Sweden? I guess it is, right? It's popular everywhere. But fixing the memory view or let's push that. Now we do have something broken currently. And what is broken? There is some constexpr or some places we're using constexpr with strings, and apparently the CI/CD pipeline doesn't like that being compiled. So we have constexpr std array somewhere. Why the hell are we getting? Okay, never mind. I thought these were standard library tests. Yeah, so it doesn't like these ones here. So this doesn't actually compile on the Clang 19 on the pipeline. We're going to see that in a second. I'll show that to you guys. Yeah, I would say more of a restaurant thing than cooking at home thing, but it's popular. Yeah, cool. I have to go for real now. Bye-bye. Hello. Bye-bye, GTX. And once again, man, well done for getting a job. And yeah, good luck, dude. Have a nice night. Like the video. Like the video. Right. What was I doing? Yeah, this. So this is what we were complaining about. So string can be constexpr, even though we should be able to use constexpr strings, right? Because we are, I think we're on CMake. Oh, sorry, C++23, and standard strings have been constexpr since 23. Or am I wrong? I'll be reporting on my mental state at HPE. I'm starting on the 3rd of March. Yeah, dude, please report it to us, dude. Would you work there again? All right, so if we look at the constructor, we can see whether or not they are constexpr. There you go, constexpr since C++20 basic string with a const allocator. Yeah, it seems to me that it's constexpr. So I don't understand why this has been complained at. So Clang 19, we do have, yeah, std C++23 here. Very interesting indeed. Cannot have non-literal type. This, aka const basic string. I mean, we can obviously just change this, but yeah, I guess. What? Yeah, even like I think we have to change it anyway, but what is going on here? So we have the headers being held as a string. And how are they being used? They are being used in here, headers.cstring, right? What if we just change it to car stars? Does it work? ISO C++11 does not allow conversion from string literal to car star. That sucks. Now the other question is, why does it build locally and it doesn't build on the pipeline? Maybe we can fix the pipeline instead. So we do want to get constexpr strings working though, because it should be, in theory, working, right? I'm soon at the point where I need to record tutorial guide videos for the systems I'm developing. Hype, getting closer. Oh yeah, so your HR thing, right? I guess yeah. Oh man, if you need me to help you, I mean, I'm a cheap guy. I can give you some advice, man. Yeah, I mean, the only advice I'll give you, Robin, is just write scripts, man. Just write scripts, rehearse it before, and then record it as if you're a natural. Because that is the change, right? So obviously in the stream here, I don't rehearse anything. That's why I sound like an idiot all the time. But if you watch my recorded videos, I tend to have at least a script in front of me, or I tend to read a rough plan of what I want to talk about before. So it sounds a little bit more professional. And yeah, if you're aiming your content for like marketing purposes, then you should absolutely just sound professional and not like you just picked up a camera and started recording. That's the only advice I'm going to give you, and the advice that's going to make your content look really good. Absolutely. Plus, I have recorded a lot of videos with scripts before, so it's not new to me. Yeah. Good. That is good. Try and get a teleprompter app. I found out that it makes a huge difference. So my setup here is like I've got a arm here for like the second camera that I have, or a phone. I have my webcam that I'm talking to you guys right now. And I have like at least 3 different phones lying around that I don't use. So what I've done with one of them is I've downloaded a teleprompter app, and I use that to literally go through the script like slowly. So I can kind of read the script as if I'm looking at the camera. I just put it literally just below the camera. So you sound very natural because you're kind of reading at a good pace, and you look very natural as well because you're kind of looking at the camera like I'm doing now. So yeah, try that out. You might like it. Otherwise, you're going to be looking like script, and then you're going to have to like either edit those bits where you're looking at the script and then talking, or you can just use the teleprompter, which is much nicer. Yeah, I literally just downloaded an app called Teleprompter. I do need to start recording stuff again, though. I think I'm going to record some CI/CD stuff this week for sure. I was just doing the script yesterday, so I'm going to maybe record it tomorrow, have it edited by maybe Saturday-ish. Yeah, that sounds good. Yeah, so let's use ChatGPT in this case. So why do I get the following error when using std string in constexpr arrays in C++ 23 with Clang 19? So it should be able to figure out, more precisely, is not a literal type, and therefore it cannot be used in constexpr variable. Why is std not a literal type? Oh, right. So it's not really the fact that the stud string isn't constexpr, it's the fact that std string is not literal and is not a literal type. You must have a trivial or constexpr destructor. However, std string does not meet these requirements. Wait, what? I don't even know what this is. This is the first time I'm kind of looking at a literal type. I guess literal type would be something like a number or an integer float or a C string, right? They fixed a bunch of performance stuff yesterday, did seed script that populated the systems with thousands of customers and 10K plus work orders just to see that nothing crashed in the site. That is good, yeah. I mean, running those tests is really good. I mean, if you have like a lot of money to spend, I recommend some load tests as well. So like just have it running and hire a bunch of, I guess, AWS machines. Just write a what do you call it? Some Terraform scripts to get them up, and Ansible script to actually get them to kind of ping your service. So like you maybe do like 100 clients per machine, and then have literally something like 10K customers connecting at the same time and see if things still run. I'm an expert in doing that. I did a lot of that in my current company, just load testing the shit out of it. So I've developed some really good scripts to do that. For a type, literal type, it must satisfy a certain requirements, including it must have a trivial constexpr destructor. All of its non-static members must be of literal types. However, std string does not meet the requirements because It manages a dynamic memory allocation, heap-based storage, which is not context friendly. Its destructor is not marked context because it performs dynamic memory allocation. So what has changed in C++23? C++23 introduced context support for std string, which allows std string to be used in context under certain conditions. However, Clang 19 does not yet fully support context strings. Some compilers like GCC have better support for this feature. To avoid, consider using constcastar. Yeah, let's do that instead, I guess. Absolutely disgusting. Once again, Clang has let us down. Clang has let us down. So yeah, we've looked at that before in our other projects, so it would be nice to do as well. Not our main focus right now, though. Yeah, it's not your main focus. I mean, it would only be your main focus if you're actually releasing it to like a lot of people at once. But if you're just having like maybe up to 50 customers, is really not worth it, man. Even if they're all online at the same time, they're not gonna like put a lot of load through it. The only risk you have is obviously, you know, DDoS, but everyone runs that risk unless you're running some fancy Cloudflare gateway in front of it. So okay, headers. Yeah, there you go. And just like that, we should have fixed the pipeline. So yeah, I've been really thinking about getting into, I guess, startup creation now. So my friends have this like Fight Hub thing. So it's a matching algorithm, I guess. It's a matching app. Let's see if it's up now. No. Is it firehub.com? There you go, firehub.uk. And they've made a really good job of creating it. So I kind of want to help them out at some point, just so I can get some experience on what it is to actually have like an application written and, you know, deployed out there to people. What I really like is this feature they've got here, though. That is really cool. I don't know how they did it, but my friend Ryan is really, really good at like UI stuff. So yeah, they have a bunch of customers already. So I kind of wish I helped them out a little bit more, because it's such a good idea. I really like the idea, but so issues, pull requests. There you go. So we still failed. Why did it fail? Oh, it's Clang format now. Amazing. What is it? Should be Clang formatted. Okay, yeah, we can Clang format things for sure. So right, I guess CPP lint again. And this is what? Where is this? Git add, and this is going to go into a fix up commit. I'm going to edit it as well because there's a typo. Let's amend that. Oh, yeah, commit, amend. There you go. Memory. There you go. Okay. Now, hopefully this should pass 100%. We'll wait for it. I don't know what GitHub did recently, but their containers or the self-run or the GitHub run containers or machines or workers, whatever they're called, workers, by the way, that's the right name. They are really fast now. They didn't used to be this fast. It just, look, picking up or the initializing the container is 17 seconds. It used to be something like 50 seconds. So they've really worked on optimizing that. And the build is like really, really fast as well. It's probably faster than my machine, which is interesting. Okay, we're building. We're building. Yeah, I think I'm definitely going to add mscript and compilation to this, just to make sure that we can compile this in a for WebAssembly. I want to do it locally first to make sure that we can see the whole app online, and then we can add a CI step to actually automatically do it every time. That'll be really cool, and maybe we can deploy it automatically to our website. That'd be the dream. Dude, I've added so many tests. They are actually what's taken the longest to build here. Yeah, we've actually gone past the emulation as well, the emulator compilation. So there's no reason why it should fail. There you go. And we have fixed the pipeline, I think, unless some tests start failing now for any odd reason. This is probably, I'm going to be honest here, probably the most well-tested 6502 emulator that there is. Like, I've added so many tests to every single instruction. That's probably what's been, what's caused me to take something like 5 or 6 months to finish the project, which is crazy. I know, crazy, crazy, crazy. Not what it is. I just wasn't feeling confident that this was working unless I had like 10 tests for each instruction. Right, yeah, good. So build succeeded, that means we can merge this, hopefully. Merge pull request. Commit message. Okay. Extended description. See, they've added this as well, which is nice. Okay. And delete the branch. And just like that, we've completed another, I guess, feature for the 6502. I remember when you started, this feels like 10 years ago. Yeah, it was literally, I think it was at the start of last year, right? No, it can't be. It can't be. Like, what? When did I start this? I'm interested now. I am interested. When was the first stream that I did for 6502 emulation? If I go on playlists, surely I created a playlist for this, right? Yeah, I did. There you go. I need to update it because most of the new videos aren't here. 11 months ago, dude, it's nearly a year ago. In all fairness, I did stop developing anything for this for like, I think it was 4 months last year. I just got tired of it. And recently I only continued it because I want to do some ImGui, really. That's why we picked it back up. But yeah, it's been a while. It's been a while indeed. It's funny because in the first stream, we actually managed to run the code that we're running now, right? Let's see. Did you actually send it to me here? I can't remember, dude. Which, by the way, Robbie, we've been friends for over a year, man. That is really good. That's a long time. Oh yeah, basic graphics with Raylib. There you go. It would have been this one. The second stream, that's when we we did it, right? Or maybe not. There you go. It would have been this one. Yay, there you go. That was the first time he gave me the code. Hey, look, it's me in the chat. Yeah, it's you in the chat, man. Let's pixel art. I look so young and full of hope in there. A year older now and less hope for sure. We have OG viewer for the win. Indeed, yeah. Right. With that in mind, man, I'm gonna call the stream here. So thank you all very much for joining. Thank you, Robin. Thank you for being in the stream, dude, for literally over a year now. That was probably not the first time you joined the stream, so yeah. And yeah, I guess I'll stream again maybe on Friday. Let's try Friday. Maybe I'll do something different. Maybe some Raspberry Pi programming again. I kind of feel like people are getting bored of the ImGui shit now. We've done like 4 or 5 videos on it. So yeah, thanks for the stream. Thank you. No worries. So I hope you guys have a good night, and I'll see you all next time. Bye-bye.